Now let's see antisymmetric relations. By the name you might feel that whatever is not symmetric must be antisymmetric, but it is not right. With examples I'll explain you this. Let's see the definition. A relation capital R is said to be antisymmetric if x is related to y and y is related to x through R, then x equal to y for all x comma y belongs to A. So what they mean to say by this definition is, if you have any two elements, or you are not supposed to have any transitive elements like x comma y and y comma x. Only exception is it is allowed only if it is of type x comma x. Okay, I'll take an example and I'll explain you. See this. Let us assume that capital A equal to 1, 2, 3, and we are talking about the relations possible on A cross A. Okay. Now let's take some examples. R1. So R1 equal to 1 comma 2 and 2 comma 1. Okay. So this type of relation is not antisymmetric. Okay. It is not antisymmetric, but it is symmetric. Okay. So why is it not antisymmetric is, we have elements of type x comma y and y comma x. That is why it is not antisymmetric. So you might feel that if a relation is symmetric, then it is not antisymmetric, but it is wrong. I'll just give you one more example. See this. Let us say R2 equal to 1 comma 1. Right. This is antisymmetric because we are going to allow x comma x type of elements even though they are symmetric elements. Got it? Therefore this is antisymmetric as well as symmetric. Earlier was not antisymmetric, but it was symmetric. Therefore we cannot say that antisymmetric and symmetric are complements of each other. Okay. So let's see this. I'll give you one more example. R3, let us say 1 comma 2 and 1 comma 1. So this is antisymmetric because we don't have elements of type x comma y and y comma x. If you have any elements of type x comma y and y comma x, they are equal, x equal to y. So this is definitely antisymmetric but not symmetric. Getting this? Now let us see one more example. R4 is, let us say 1 comma 2, 2 comma 1, and then let's say 2 comma 3. This is not antisymmetric. Why is it not antisymmetric? Because of the presence of these elements, right? Because you have x comma y and y comma x. Such elements should not be present. If they are present, that cannot be antisymmetric. So this is not antisymmetric, right? But then this is symmetric. Sorry, it is not asymmetric as well. The reason is 2 comma 3 is present, x comma y is present, but y comma x is not present for this particular element. Because of the absence of the element 3 comma 2, it is not symmetric. Got it? Therefore you should not think that if an element is symmetric, then it cannot be antisymmetric, or vice versa, right? So the relation between symmetric and antisymmetric is bit confusing. So use these examples, you'll understand it. So what does antisymmetric say is, in a relation you are not supposed to have x comma y and y comma x together. If it happens, then it should happen only in the case when x equal to y. Other than this, there should not be any such elements present. That is what antisymmetric relation says. Okay. So if you want to take more examples, you can even see this. I'll try to give you some examples. 1 comma 1, 2 comma 2, 3 comma 3. Right? So what can you say about this relation? Is it antisymmetric? Yes, it is antisymmetric. Why? Because there is no presence of the elements such as x comma y and y comma x. Even if they are present, only x comma x is present. Therefore this is definitely antisymmetric. What about symmetric? Yes, it is symmetric also, right? And what about this reflexive? It is reflexive as well, isn't it? So we can form many such relations. Now the question is, what could be the smallest relation what could be the smallest relation that is antisymmetric? Okay, so see this smallest relation I'm talking about, let's say R6. If the relation does not contain anything, then what can you say about that relation? It is going to be antisymmetric. Why? Because antisymmetric case fails only when there is x comma y and y comma x type of elements, but when there are no elements at all, it is definitely antisymmetric. Therefore, the smallest relation which is antisymmetric is going to be empty set, which means the cardinality of the smallest antisymmetric relation is 0. Cardinality means number of elements, isn't it? So the cardinality of the smallest antisymmetric relation is 0. What about the largest antisymmetric relation? How can you form the largest antisymmetric relation? Let's see this one. Let us say or 7 I want to write about it. Okay, before discussing about it, let's see what are the total elements that you have in A cross A. Then from these total elements we can find out how to form the largest relation. Okay, I'm trying to write total number of ordered pairs present in A cross A. Okay, so what are the ordered pairs? 1 comma 1, 2 comma 2, 3 comma 3. These are all diagonal elements, and the non-diagonal elements I'm just grouping them together in such a way that transitive elements are together. Okay, now I want to find out the largest relation which is antisymmetric. Now what can you say about the inclusion of these diagonal elements? If I include these diagonal elements, is the relation still going to be antisymmetric? Yes. So they are allowed in antisymmetric relation. Therefore, let me include these diagonal elements. What are they? 1 1, 2 2, 3 3. I am going to include these 3 diagonal elements, because even after including these diagonal elements, it is still going to be antisymmetric. Now I should not include these 2 together, but out of these 2 I can include any one of them. Why? If I include both of them together, then it is not going to be symmetric, isn't it? Then it is not going to be antisymmetric. Got it? A comma x comma y and y comma x, both of them should not be present at the same time, right? You can have only one of them. So from these 2 you can choose any one. Let us say I am choosing 1 comma 2. If you have chosen 1 comma 2, then 2 comma 1 should not be there, right? Or if you choose 2 comma 1, 1 comma 2 should not be there. Therefore, the element which I am going to choose is not relevant here, because I am interested in finding out the number of elements that are present in the biggest relation which is antisymmetric. Therefore, it does not matter whether I choose this one or this one. The number of elements in the largest will not change. Okay. Similarly, from this pair you are supposed to take only one. Now which one do you want to take? 2 comma 3 or 3 comma 2? You can take anything. If you include 2 comma 3, don't include 3 comma 2. Now from this one, what do you want to choose? So 3 comma 1 or 1 comma 3, you can include any one of them. So let me include 1 comma 3. Then you are not supposed to include 3 comma 1. Got it? So what is the largest? This is the largest relation which is antisymmetric. So how can you say that it is the largest relation which is antisymmetric? If you add any element into this set, into this relation, then the relation fails to be antisymmetric. If you try to add any one element, right, for example, if you try to add 2 comma 1, because 1 comma 2 is already present, adding 2 comma 1 is going to make it not antisymmetric, right? Similarly, you cannot add any one of them, any more elements. That is why this is the largest relation which is antisymmetric, which is possible on the set A equal to 1 comma 2 comma 3. But then I want a generic answer, which means if cardinality of A is n, not here the cardinality of A I have taken it as 3. If the cardinality of A is n, then what is the cardinality of the largest antisymmetric relation? Then how can we form? So see this. In order to get that, I am just following the same logic. I am just trying to form the largest relation which is going to be antisymmetric. Now how can we form it? See, if you have n elements, then total number of ordered pairs on A cross A is going to be n square, right? Now out of these n square elements, some are diagonal elements, so you include all the diagonal elements in RL, because including them does not alter the definition, right? Therefore include all the diagonal elements. So what are the diagonal elements? 1 comma 1, 2 comma 2, so on, n comma n. Yes, all the diagonal elements are included. How many are there? N elements, right? And now from the remaining non-diagonal elements, you pair up all the transitive elements. Transitive elements means the elements of type x comma y and y comma x. Now you include only one of them. For example, you include only 1 comma 2, not 2 comma 1. Likewise, you can include 1 from the pair. So how many pairs will be there? How many pairs of transitive elements will be there? We know this. If the total elements are n square, from which if you have removed diagonal elements, then the number of pairs will be half of it. This is the total number of remaining elements, n square minus n, then the number will be half of it. Number of pairs will be half of it. So from each pair, if you take one element, the number of elements that can be added is going to be n square minus n by 2. So what did you understand from this? The total number of elements in the largest relation, which is antisymmetric, is going to be n plus n into n minus 1 by 2, which happens to be n into n plus 1 by 2. This is the cardinality of the largest relation, which is antisymmetric. What about the cardinality of the smallest relation, which is antisymmetric? 0, right? So smallest is 0 and largest is this one. Okay, now we shall see what is the relationship between with the antisymmetric and symmetric, antisymmetric reflexive, like that. Okay, we shall see the relations now.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.